Moving on to Africa, climate change that will actually be experienced in Africa is a function of those large-scale changes that I've talked about. Will the global temperature increase by 2 or 3 or 4 or 5 degrees? And then how those large-scale changes propagate through to smaller scales to affect regional and local weather and climate. And trying to understand what the potential outcomes are at the local and regional level is the domain of climate modelers. Now, climate modelers use climate models to simulate the whole climate system response to greenhouse gas forcing of climate. And these climate models, through necessity, are approximations of the real climate, but they're the best tool that we have to try and understand how regional climate will change in the future. The models have improved over the years through years of evaluation and development, but they're still not perfect. And so we can't really use them to predict exactly what the future is going to do, but they do give us information on what the plausible possibilities in the future might be under different levels of global warming. And then we can use this information from the climate models to develop scenarios of what climate might look like in the future, which can then inform our understanding of risk and vulnerability. If we look at the results from climate models, at the broad scale, there are some sort of generalizations one can make about what climate change over Africa is going to look like. If we look at temperature, where we have reasonable confidence for what the patterns of change will be over Africa, we can see that over the continent, along with actually all other continental areas, the African continent will warm faster than the global average. So what that means, for instance, is that if global warming reaches 2 degrees, then we can expect warming on the African continent, depending on where we are, of between 2.5 and 4 degrees. So the rates of warming are faster over the African continent than over the global average. The coastal regions will warm slower or more slowly than the interior regions because of the ameliorating effect of the surrounding ocean. And dryland areas, so the semi-arid and arid areas of Africa, will warm much faster than the more humid areas. So coupled with these more general changes in temperature that have been described is our confidence in the fact that temperature extremes will also increase. And one of the consequences of this is that what's considered an extreme temperature today will actually become much more normal in the future. So today's extreme become the normal of the future, and the extremes of the future take us way outside of what we've experienced up to now. Moving on to projections of what rainfall might do over Africa, there's some general patterns that emerge. First of all, the areas that are currently dry in Africa would appear to seem to become drier. So this is the semi-arid areas of the subtropics and the arid areas of the subtropics. So anywhere from sort of about 15 degrees north and south to 25 degrees north and south, those big arid bands that include the Sahel of West Africa and the Sahara Desert and the Kalahari of Southern Africa. In addition, these dry areas are expected to have more variable rainfall as well. So in addition to becoming on average drier, the frequency of dry and wet years will also increase. So it'll be a much more variable and stressful rainfall climate as well. If one goes to the northern and southern tips of the continent, where we have the Mediterranean climates of Africa, those are also projected to become drier in their. So the winter rainfall regions will have lower rainfall. And then in the tropical areas, which are generally the wet areas of Africa, especially East and Central Africa, there's a projection for more rainfall and wetter conditions. And across all of these areas, regardless of whether the average rainfall is going to increase or decrease, almost all regions show an increase in rainfall intensity. So when it does rain, the rainfall is going to be stronger and more intense, leading likely to greater rainfall damage and flood damage, and the number of days with rainfall will decrease. So the length of dry spells in between rainfall events will increase as well. The important thing to note, of course, is that the extent of these local changes do scale with the global temperature rise. So the kinds of changes that we've seen will become more severe if global temperature increases by 4 degrees rather than 2 degrees. And also, if global temperature is going to increase by 4 degrees rather than 2 degrees, it will happen at a faster rate. The rate of change will be faster, and therefore also the local rates of change will be faster, which means that the time that's available to respond will be shortened. So you might get a 25% reduction in rainfall over 20 years rather than 50 years if the rate of global warming is faster.